Welcome to my video. This is a tutorial of using the PsychoPy software to build cognitive psychology experiments. Specifically, we're using the builder mode of PsychoPy. In this tutorial, I'm going to show you how to create a new experiment from scratch. We're going to take baby steps to create each and every event of a new experiment. And along the way, I'm going to discuss the basic programming tricks about PsychoPy, as well as some general tips about programming with the Python language. This video will be the most helpful for beginners in programming in the field of psychology, such as first-year graduate students. And also, this video may be of interest to people who already know how to program using other softwares such as ePrime or MATLAB and would like to switch to PsychoPy instead. As you can see, this is the interface of the PsychoPy software, and this experiment, which is a visual search task, is an example I just finished building myself. I'm going to use this example program to walk you through the basics of PsychoPy and also show you how to recreate the same task from scratch. So the first thing I'll do is to show you what the experiment will eventually look like once it's finished by running the program, and then we can look through the basic structures of experiment design and finally open an empty program to recreate the task. So get ready and follow along with me. First, to run the experiment, let's click the green play button here, and an output window is shown here. It shows the output from running the script. Sometimes if the program refuses to run, the error messages here may be informative for you to debug. And then we're prompted to enter the participant number. We can leave it blank for now as we're just test running. And then we also need to enter the program version. Different versions are used to show different stimuli to different groups of participants, which is for counterbalancing purposes. For now, let's first see what version A will look like. Welcome to the experiment. Here is the instruction. You will see multiple shapes appear. Your task is to find a target circle and report the location of the dot inside the circle, which could be either left or right. If the dot is on the right of the circle, press the right arrow key. If the dot is on the left of the circle, press the left arrow key. Try your best to respond as quickly and accurately as possible. So this experiment is a pretty basic button pressing task with two alternative force choices, in which speed and accuracy will be important data to collect. And there's a separate line of instruction down below. Sometimes a distractor may appear in red. Please ignore it, which will never be your target. Your target circle will always be in green. That means when looking for the circle, we only need to search through the green part of the display and try to ignore anything that's not green or anything that's specifically in red. Alright, let's keep going to see what the trials will look like. When we're ready, press one of the two response buttons to begin. It's a pretty basic visual search task and pretty simple. If I intentionally make an arrow here, I get an error message. If I intentionally not to respond on the next trial, I get a too slow error message. So there is trial by trial feedback based on whether there is a missing of response or whether there is an incorrect response. And then when we get to the end of the block that's being shown here, we also get the block end feedback message that summarizes our reaction time and the number of errors from all the trials that's been completed in the past block. And because my performance was relatively poor in the last block, I'll need to get an experimenter to continue. Okay, let's exit this program for now. and see what the other program version B, will look like. Let's wait for a few seconds for the program to launch. I'll just change the version to be B. The same welcome message. And then you can see that the instruction is almost the same as before. The task is still to look for a target circle and press one of the two arrow keys to report the location of a dot inside the circle. And the only thing that's different is that now the circle is in the red color and the singleton distractor will appear in green. So in different versions, the only thing that's different is the color assignment between red and green to be either the target color or the singleton distractor color. Okay, now let's take a look at what the trials will look like. It's pretty similar to before, and if I intentionally made a mistake on the next trial, I get an error message. If I intentionally not to respond on the next trial, I'll get a too slow message. And again, at the end of the block, we will get the performance summarize numbers. Okay, now let's exit the experiment. That's what the final experiment will be like. And now let's start from here, start from scratch to show you how to recreate this experiment step by step from the very beginning. In this tutorial, I am using PsychoPy program version 2025.1.1. One thing to be careful about PsychoPy is that different software versions may not be compatible with each other. So if you're programming the experiment using your personal computer and eventually you will be running the experiment to collect data using the computer in your lab, please be careful to make sure that the software version is the same on different computers. This is really important, otherwise your program may not even work on a different software version. Okay, let's get started and see what the interface of PsychoPy looks like and what's the function of different part of the workspace. So up here, the vertical bar shows the two bars, and down below here it shows the workflow of different events of an experiment. And if you remember from what we just ran in that example, the first thing we saw is a welcome message showing welcome to the experiment. That's here in this welcome routine. Like every block along the workflow is called a routine. And then we saw the instruction for the experiment. That's in the instruction routine. Next, we saw a message saying like, when you're ready, press one of the two response buttons to begin. That's in the ready go routine. And next, we saw the search array being presented. And based on our performance during the search, we may get an error message or a too slow feedback message. That's in this trial feedback routine. And every trial is repeated 6 times in this trial loop. This thing is called a loop. And then at the end of the block, we again got some block feedback message showing our performance numbers. And this block can also be made to repeat several times to ensure that we get enough total number of trials in this experiment. And this is a block loop. And then at the very end of the experiment, we can present to the participants some thank you messages and also debrief them about the purpose of the experiment. So this is the entire workflow of this visual search task. And if I click on different routines along the workflow, you can see that the contents are displayed in this part of the interface. This is called the workspace. And every workspace shows several different components. Every small icon here shows a component. And some component is the code component that allow us to type in our customized Python code for some more flexible manipulations. And some component is the text component, displaying some text messages such as the instruction text. And some components are the image components that they display remember in the instruction page there was some demonstration images showing what the array will look like. And some components are the response collecting components, like a keyboard here collects our key press to allow the experiment to proceed. And where do the components come from? They are selected from the list down here. As you can see, they are classified into different categories. In the stimuli category, like the most used stimuli are the polygon stimuli that can create different shapes, and also movie stimuli that can present a video, or images, or gratings to show orientation stimuli in perception experiments, or texts, or text box, or sound. And for responses, the most commonly used response collecting method is the keyboard component that can collect key pressing responses, can collect what key is pressed, can collect the reaction time and the accuracy. And if you want to be more flexible, you can use an external joystick and collect button pressings on the joystick. And you can also use a microphone to collect participants' voices. And also I use a mouse component to collect the mouse clicking or mouse movement trajectories, etc. And in the customized category, the most commonly used is the code component that can allow you to put down your own Python commands for more flexible experiment design. And PsychoPy is also compatible with eye tracking and EEG designs when you customize the code to connect with an eye tracker or EEG amplifier. But in this tutorial, we're not going to cover those. In this tutorial, we're only going to show you a very basic example of creating a purely behavioral experiment. Okay, now it's time to open an empty program and recreate this experiment from scratch. To open an empty program, just click on this icon here, and this is what the workspace will look like when nothing is created yet. And the first thing we do before programming the experiment is to set up the monitor settings in this monitor center icon. As you can see, I have several monitors already set up here, and today I'm using a MacBook. And if you want to enter a new monitor setting, just add a new, click new here and enter a monitor name, and it will appear up there. And for my MacBook, I have already measured everything and entered its parameters down below. You will need to enter the screen distance, which refers to the viewing distance from the observer's eyes to the center of the screen. It's in the unit of centimeters. For me, I just entered 50 centimeters. But in a rigorous experiment setting, you may need to manually measure the distance between the participant's eyes to the center of the monitor and enter it here. And next, enter the size of the screen in pixels. For my screen, it's 1512 times 982 in pixels. And then enter the width of the screen, also in centimeters. You can either get this value by manually measuring the width of your display, or if you know that you're using a 13-inch MacBook, maybe you can Google what's the screen width for a 13-inch MacBook. And after entering all these values, click Save, and then we can shut down the monitor center. Next, enter more detailed settings of the experiment by clicking on this gear icon. Let's come up a name for our experiment. I'll just call it Visual Search Task. And then we're asked to select whether we want to use piloting mode or running mode. I always like to use the running mode even if I'm just piloting the experiment, because the running mode allows us to see the experiment in full screen. That's exactly what the participants will see, whereas the piloting mode only displays the experiment in the center subset of the screen. And then for PsychoPy version, I would suggest leaving it blank, just choosing the blank option here. If you choose a specific program version, even if you choose the one that matches your current version, that will probably give you more trouble when you try to run it on a different computer. So leaving it blank will give you the maximum flexibility when running it on different devices. For the experiment info, these are the information we are prompted to fill out when we try to run the experiment. Like when running the experiment, we were asked to enter the participant number, and I would delete any default number here. And here it shows experiment session, but in this task, we don't care about the session, so I'll instead change it to experiment version. And I'll enter version A as a default, so we don't have to manually type the letter A every time. If you need to enter more information when running the experiment, like the participant's gender, you can add more entries here by just clicking on the plus sign. But for this task, I don't need so much information. And next, in the Screen tab, we will need to let the software know which monitor we're using. Because we're using the MacBook, I'm going to enter the MacBook name here. And this name has to match the name we set up in the monitor center. It has to match the name we entered all the parameters for. And next, for the unit, I would like to use the degree instead of height. Degree refers to visual angle. So if in a paper we always report the size of our stimuli in visual angles rather than in pixels or centimeters, like for the circle stimuli in this experiment is 1.5 times 1.5. So if I choose the unit to be degree, when specifying the parameters for the circle, I can use the exact parameter I'm going to report in a paper to enter into the program. This makes it really convenient and avoids additional steps of converting the size between different units. For background color, PsychoPy uses RGB color space, using 3 digits to define the color. In the example we just saw, the background color was black. And to get black, I can either use the 3 digits to define it, or alternatively, I can just type the word black in quotation marks. Classical color names like this can be recognized by PsychoPy. Next, audio, we don't need to change anything there, and also not for online, not for eye tracking, not for input, and then for data. So here shows what a data file would be named after when you save data into after this experiment is finished running. Currently, you can see that it has 3% s. These are placeholders for a string variable, and here are the 3 string variables that will be listed in the file name. First, the participant number, and then the experiment name, and then the date that the experiment is run. If you would like to have additional information in the file name, for example, if you would like the program version to also appear in the file name, you can add another variable, maybe after the participant number. You can add the program version here, and also you will need to correspondingly add an additional placeholder for an additional string variable here. And in PsychoPy, the data will be saved as a CSV file by default, and it will be saved trial by trial. Every trial will be a separate row in the CSV file. But if you would like it to be saved in a different format, like be saved as an Excel file or as a summary, you can check different boxes according to what would you like the data to be saved. And after these basic settings, I'm gonna click OK. And then before we do anything else, let's first save the file by clicking on this save icon. I'm going to create a new folder for this experiment. I'm gonna save it under documents and create a new folder called PsychoPy tutorial. And I'm going to call this experiment tutorial example. Okay, then it is saved with the tutorial example displayed here. Next, we are going to create the events of the experiment along the workflow following time order. As you can see now, the default routine here is called trial and it doesn't have any components yet. But in our experiment, the first routine is the welcome page. So I'm going to rename the trial to be welcome. And the first thing we want to determine before the start of the experiment is that we want to decide what stimuli to present to the participants based on the program version. Remember that? Version A means green color and red distractor, whereas program B means the opposite assignment. And to do that, we will need to get a code component under the custom categorization. And in a code component, the default window looks like this. You would enter the Python code on the right, and it would be automatically translated into JavaScript displayed on the right. Well, this function will come handy when you try to run the experiment online, because that will require the experiment to be programmed in JavaScript. But for offline, in-person experiments, just programming it in Python would be enough, and we don't need the code to be translated into JavaScript. And the translation of PsychoPy is usually not so accurate, so even if it has the auto-translation function, I wouldn't usually trust the code that's automatically generated from my Python code. And for now, since we're not trying to run the experiment online, I'll just keep the Python display for simplicity. And you can see that there are so many different tabs above the code box. And the most commonly used tabs are begin experiment, begin routine, each frame, and end routine. So what are the differences between them? If you put down your code under different tabs, your code will be executed at different timing during the experiment. For example, when you put down your code under the begin experiment tab, the code will only be executed once when you first run the experiment at the very beginning. And if you put down your code under the begin routine tab, that means the code will be executed once every time the routine is run. You remember that? In the example we just saw, the search array was repeated. The search array is the main trial event, which was repeated 6 times in a block. So every time the search array is repeated, the corresponding code under the begin routine tab will be executed once to generate different stimulus patterns of that array. And also each frame means that the code put down here will be rerun very frequently at every time the screen refreshes itself. If your computer has a refresh rate of 60 Hz, that means your computer will be refreshed 60 times every second, which means that your computer will be refreshed about every 16 milliseconds. The screen will refresh once. And any code that's put down here will be executed as frequently as the refreshing frequency of your screen. We usually don't put down any code here unless the code is to check if a condition is met, and then if the condition is met, the trial will be immediately terminated or something immediately should happen. We should put it down here. And then at the end routine tab, we usually put down the code to save the data manually here because the responses are usually not obtained until the end of the routine. So any code to save the data should put down here. And also sometimes although the code would run pretty fast, it still takes some time to run the code. So if there is some code that we don't want that the time to run it delays the presentation of our stimuli, we should put it down here at the end routine tab so it won't be run until the end of the trial event. Okay, so for this welcome routine, what we need to decide is to determine the color assignment to the target and the distractor based on the program version. So in Python, if we want to make any notes to ourselves, we usually type this pound sign to annotate the code. So this is for counterbalancing purposes. We want to assign different colors to target and distractor based on version. And to do that, to do the counterbalancing assignment, we need to get the program version using an if-else statement. If it's one version, if it's version A, do this. If it's version B, do that. So if to get the program version, the syntax is exp and then uppercase in I for info. In Python, the syntax always looks like this. The first word of the syntax is always in lowercase, and then starting from the second word, the first letter needs to be in uppercase. So this gets the information that's entered in the experiment info boxes once the experiment is started. You need to get the version information. And if the version is A, we do one thing. And notice that this is double equal sign. That means checking to see if this variable matches this thing. So whenever double equal is used, is a conditional statement, just checking whether the two things at two sides of the operator are the same or not. And because A is a string variable, we need to put quotation marks around it. So if it's A, we would assign the target color to be green. For brevity, I just call the target color target car. It follows the same naming convention in Python, making the first letter of starting from the second word to be in uppercase. And I use a single equal sign here just to assign value to a variable. This is different from the double equal sign, that's the conditional statement there. And PsychoPy recognizes the color names, a certain number of very classical color names only. So definitely red and green, black and white, those classical names are recognized, but you need to put them in quotation marks as well. And then the singleton distractor color is red. And then if the program version is version B, we would do the same, except that we would want to reverse the assignment. So I'm just going to copy and paste and change a few details about it. Okay, so this part finishes the counterbalancing assignment of the two colors to different shapes in the array. And next, a second thing we may need to determine is how many blocks we want in this experiment. This information will be repeatedly used in the following routines to determine when the experiment should end and when displaying the block feedback messages, how many blocks we should tell the participants. So we might as well also specify the information early on in the welcome routine. So we can specify the number of blocks. I would call it num blocks being 6. Okay, so for this welcome routine, we only need code under the begin experiment tab. They need to be determined only once at the very beginning, but we don't need, because the welcome routine will not be repeatedly run, we don't need any code under these routines at this point. Gonna click OK to save it. So you can see now a code component is generated in this workspace. And for the welcome routine, we also need to display a welcome message. So I'm gonna create a text component. Usually we don't care about the name of the components unless it's an important component, such as it's the response collecting component that collects our speed and accuracy important data, or if there are several repeated same components, like several polygon components showing the circle, the square, the hexagon shapes in our trial, we will probably want to name them to let us know which is which. But for just a welcome message, we usually don't care about the name, just use the default option. And we need to set when the text message will start to be displayed and when it will disappear. We want it to be displayed at the very beginning, so 0, and we don't want it to disappear until participants press a button to proceed. So I'm going to delete the duration, set it to be blank. When it's blank, the event will be displayed until forever, until the end of the routine. Okay, and for the text, I'm going to say, welcome to the experiment. And then under the layout tab, we want it to be precision at the center of the screen. And when the unit is set to be degree, you can imagine the screen as a Cartesian panel, and with the center of the screen being 0, 0 in the coordinate. So 0, 0 means the message will be displayed right at the center. And the spatial unit is default to be from the experiment settings. We set it to be degree in the experiment settings, but if you want it to be something else for a specific event, you can also customize it here. And wrap width is how wide the text could be displayed. If you don't set any value here, it's by default to be displayed pretty narrowly. So we want it to be spanned across the screen. So I put down 30 degrees here to make it displayed widely. The appearance, we want the text to be displayed in white color. We don't need to change anything here. And for formatting, we can change the font if we like. And we want the text to be displayed relatively large. So I'm going to change it to be 1 degree. Okay, click OK to save the component. And then the next thing we want to add is a keyboard, is something to collect a response in order to force end the routine. for the keyboard, we also wanted to start at the very beginning and never end. And check this force end of routine box so that whenever a key press is detected, the screen will flip to show the next routine down the workflow. And here it shows a number of allowed keys. And when administering the experiment in person, I will usually use a secret passkey to only allow the experimenters to control the end of the finish giving the instruction. So in our lab, we usually use P for proceed. So I'm going to only allow for the P key. And when under the data tab, sometimes we want to store the key press, but for this kind of key press that's only used to force end the routine without any data attached to it, we can save nothing. But for the responses towards the search array target, we would want to search. We would not want to save the first key press. But for now, I'll just set it to nothing. Okay, and save the key press. Now we have finished creating all the components for the welcome routine. You can see that each component has a bar spanning across the screen, and here is the timeline showing you the duration of each event. Because we set the duration for these events to last to forever, they don't stop at any point. But if we set the duration, say, to last for only half a second, the bar would stop here instead. We will see that later when we get to the trial event. Okay, let's now test run this only routine to see if it looks like what it's supposed to be like. In this tutorial, we will test run our program pretty frequently. Almost after building any routine, we test run it once to debug in a timely manner. Okay, perfect. So welcome to the experiment. That's the same welcome message we saw in the example program. And if I hit the P key, which is the secret passkey we set, the experiment would be ended. All right, perfect. So that's it for the welcome routine, and let's keep going to build the next one. The next routine is the instruction routine. So to create it, I hit insert routine and click new and call it instruction. And click on the timeline, the location where you want the routine to appear. All right, a new routine is created. And in this instruction routine, we want to display the text instruction. So I'm gonna click a text component. And for this text component, I wanted to display the basic instruction text. If you remember, that's the one on the top of the screen, just instructing participants about what target to search and what responses to make. And there will be a second instruction text down below at the bottom of the screen telling participants about what's the distractor color to ignore. We're going to work on that later, but for this one, I'm going to call it instruction text, and also we want it to last to forever, never end. And for convenience, I'm just going to copy and paste the instruction text I had in my other example program, which is the same as what you saw when we test run it. And for layout, we want this instruction to appear at the top of the screen, so I'm going to change the coordinate for the thing to be put at the top. And then I am going to change wrap width to be 30 for it to span across the screen. And then for formatting, we want it to be relatively big. Say I change the letter height to be 0.8 visual angle. Okay, and on the instruction screen, we also use some illustration images to show what the trials will look like. And for convenience, I have already copied these illustration images to the PsychoPy tutorial folder. That's where we saved our example program. I've copied these in illustrative images that I created beforehand in PowerPoint into the same folder as where the experiment program is saved. And as you can see, I have the image called greendemo.png that shows what the search array is like when the condition is green. And reddemo.png shows the search array when the target color is red. And I have greenfinger.png shows the response illustration. And redfinger.png showing the response illustration for the red target condition. So we're going to display different illustration images based on the condition. To do that, we will need to again use a code component, set it to use Python only, and because this code will only need to be executed when it gets to the instruction routine, but not at the beginning of the experiment, I'm going to put it under the Begin Routine tab, but theoretically, it doesn't matter which tab I put it under because those will always, the code in either of the two tabs will be run before we get to the instruction routine. So they will all be executed to determine what image to present. Okay, this is to determine what image to present based on version. I'm going to call the demonstration image for the search array as array demo, and because the naming of the files is either reddemo.png or greendemo.png, they only differ in the prefix, that's the target color. So I can use the target color, which is the variable we previously defined in the welcome routine, plus the demo.png in quotation marks. So together, this will be recognized as either red demo or green demo. And for the finger image, I'm going to call that finger demo. And again, the format of the name is either redfinger.png or greenfinger.png. I'm going to call it target color plus finger.png. And click save. So if we add an image down below the code, we should be able to use the output from the code to define what image to get. So the first image we want is the array demo. I'm gonna call it array demo and have it displayed until forever. And to put a variable in the image rather than just the pure image name, we will have to first put a $sign. A $sign tells the software that the thing following is a variable instead of a solid file name. And we previously called the image array demo, so I type array demo here. And because the variable is a different one every time we run the software, so this variable here has to be updated every repeat. I will set it to repeat, be updated every repeat. And for the position, we want the image to be in for the array demo to be in the left side of the screen, and the finger demo to be on the right side of the screen. So I'm gonna change the coordinate to shift upper and to shift left a little bit. And for the size, I set it to be 7.7 to be a square shape, relatively large. Okay, and for the other image, we call it finger demo. Also, I want it to last to forever, and use the same trick, a $sign followed by the name of the variable, and set every repeat. For the size, because this is a rectangular long shape, I'm going to set it to be 6.8 and shift it slightly to the right side of the screen. And you may wonder, how do I know the right size for how the image should be presented? I honestly don't. I try to set a reasonable size, and then I test run the software to see if it looks correct. If not, I will adjust the size. Okay. And another thing to be careful about PsychoPy is that the code component that will decide what variable the later components will use needs to be put above the later components in the sequence. The components here will be executed one after another following this downward order. So whenever the code determines something more downstream, be careful to put it upward above those other later events. And then the next thing to add is the singleton color instruction. We will again need a text component, but this time things are a little bit complicated because the color of the singleton is different in different experiment versions. We will not be able to use a simple text component like the instruction text and type out the color name. Otherwise, that won't be updated based on different version. In this case, we will need to again set the text content to be a variable, and we will have to determine the variable using a code component. But because we already have a code component here, we can keep using it, just typing additional information we want. Now we need to specify the text instruction for different distractor colors based on version. The basic instruction would be sometimes a distractor may appear in, and we would stop here, and we'll later add the distractor color at this location. And after adding the distractor color, we need another text to finish the sentence. Period, and please ignore it, which will never be your target. Your target circle will always be in, and then we will put the target color there to remind the participants again. Okay, so to concatenate the sentences, the syntax is really easy in Python. First, we want to call the variable of the singleton instruction text, maybe syn text. To concatenate different text and different variables, we just need to put text1 plus singleton color, we will need to put the singleton color at the end of this piece of text, and then keep going to combine text 2, and then put the target color at the end of this sentence. And because there is no period to end the sentence here, we will need to manually type a period. So in this way, different chunks of text and the variables are concatenated with each other to be called a singleton text. It's a variable that can be updated every time the software is run. And we save it and add another text component. This is the singleton text, and we want it to last to forever. And for here, I'll put a $sign to indicate it's a variable, and then sing text. Set it to be updated every repeat. For this one, we want it to be down below at the bottom of the screen, so change it to be a negative value for the position. And for wrap width, we also want it to span across the screen. Also want the text to be relatively large. Okay. And again, at the end of the routine, we want a response collecting method to allow us to press a key for the program to proceed. So because this key press is pretty similar to this one before, I'm just going to copy the routine from the welcome routine. Copy this component from the welcome routine and paste it here. And the name of the keyboard doesn't really matter, so just use default. So now we have everything we need for this instruction routine, and let's test run it to see if it works ideally. Welcome to the experiment, and if I click P, it should show us the instruction. Yeah, it's perfect. It's the same instruction we saw when running the example program before. We can see that the above, it's the general instruction about the target shape and the response keys. And then in the middle of the screen, it shows two illustration images. One is for the search array, the other is for the what keys to press for different target orientations. And you can see that because we run version A, the target color should be green, and the color is correspondingly displayed correctly. And down below at the bottom of the screen, you can see that there is the instruction about the distractor color and the target color. You can see it says the distractor may appear in red and the target will always be in green. So it seems like everything is working perfectly. If I click P again, it should automatically finish the program. The next routine down the stream is called a Ready Go routine. It shows the text message of pressing one of the two response buttons to begin the experiment. So to create that, let's insert another new routine and call it Ready Go. And insert it here. To create the text message, because this is a pretty simple text, it's not a variable, doesn't need to be updated based on versions. Let's just type it here. And we want this task to also last to forever. And we want it to be presented at the center of the screen and span widely across the screen. And we want the text to be, again, relatively large. And we need another keyboard component here to allow participants to press one of the two response buttons to begin. To allow two response buttons, because the response buttons are the left and right arrow keys and they're already listed here by default in the program, left and right, all in lowercase letters in quotation marks, and different keys are separated by a comma. So if we only allow one of these keys, participants can only force in the routine to proceed by pressing the response buttons. This will make sure that their fingers are back to the response keys, which they need to immediately press once the experiment starts. And check the force end of routine button. And for this response, we again don't need to collect any data because it only serves to get the experiment started. And now let's run the program again. Welcome to the experiment. If I press P, it shows me the instruction. And if I press P again, it should show me to press one of the two response buttons to begin the experiment. And now let's try to press a different key other than the two arrow keys. If I press P again, the program doesn't allow me to proceed, but only if I press one of the two arrow buttons, the program would terminate. So it seems like our keyboard component does work to only allow the predefined keys we set. Down the stream, the next routine we want to create is the search array routine, which is the most critical one in this experiment as it presents the search array stimuli for participants to perform the visual search and also uses a keyboard component to collect the response towards the target that will contain the critical reaction time and accuracy information as independent variables in this experiment. So to create that, let's insert a new routine and call it search array. And the most simple thing in the search array is the central fixation cross that's always there and independent of the program version. So let's just create this simplest thing first. I'm going to just use a text component and use a plus sign to represent the fixation cross, but you're welcome to use some more complicated fixation configurations such as the bull's eye fixation that's been shown to better at preventing eye movements. I'm going to call it fixation, and it's supposed to start from the very beginning and last for 3 seconds. In this experiment, we want the fixation to be presented alone for 1 second at the beginning of the trial, and then the search array will be presented for the subsequent 2 seconds. So altogether, the fixation will be displayed for 3 seconds. We want it to be presented at the center of the screen, and we don't have to care about wrap width because it's just a tiny dot. We want it to be white and relatively large in font. Okay, and then the other components of a trial includes the several shapes of the array. Remember that in the example we saw from running the example program, there was a circle, which was the target shape, and also a diamond, a square, and a pentagon. The 4 shapes comprise the search array. The shapes are going to be created by using the polygon component. We can create different shapes by specifying different forms in the polygon. But different program versions of the experiment would require for different shapes to take on different colors. And also, we will have the 3 non-target shapes take turns to become the color singleton distractor. Those effects will have to be created by using the customized code function or using an embedded Excel file to better match the probability of different events. We will talk about that later, but first let's just create the basic structure of the search array by getting the circle, the diamond, and square and polygon ready. First, let's create a circle. It should be displayed starting at time 1 second because the fixation alone needs to present it for 1 second, and the circle will be presented for 2 seconds. And let's set it to be a circle. For the size, we want the circle to be 1.5 times 1.5. And for the position, because we want the location of the different shapes to be fully randomized, that will be the only way to force people to engage in a visual search without having the target always presented at a constant location. So I'm going to set this as a variable called circle lock. Notice that I didn't include a $sign at the beginning of the variable name. That's because there's already a $sign that's already included by default in the position variable. And I'm going to set it to update every repeat. For the circle, we don't know what color to use for it yet because it depends on the program version. So this needs to be a variable as well. Let's call it circle color, set to be updated every repeat. And for border, we don't want it to have any border, so I'm just going to delete the border color. And yep, no need to change any other thing. And after creating the circle, you can see that on the timeline, it now starts at 1 second and lasts to the end of the event, which is 3 seconds. And the search array will be presented for 2 seconds. Using a similar manner, we can again use the same polygon component to create the other shapes. But because the other shapes all share some similarity with the circle, I'm just going to copy and paste the circle and change a few details about it. Let's create a diamond next. And then the name is diamond and the duration should be exactly the same, but we now make it a rectangle. And for the layout, to make different shapes appear to be equally large perceptually, we need to resize the diamond to be slightly smaller than a circle, so the area size will be perceptually equal eventually. And let's call it diamond lock. And because it's a diamond, the rectangle needs to be rotated 45 degrees. I set the orientation to be 45 to do that. And the color needs to be the diamond color. Nothing else. And again, in a similar way, I paste the circle again. This time I call it square. For the square component, I first need to change it to be a rectangle and again change it to be the same size as the diamond, except that I don't rotate it anymore, and call it square lock. Change its color to be square color. In a similar manner, I finally create the hexagon shape. For a hexagon, because the default shapes doesn't include such a complicated polygon, I have to select a regular polygon and manually enter the number of vertices to be 6. And then I want the polygon to be the same size of the circle. No need to change that, but set its location to be hexagon lock. And set its color to be hexagon color. We have all the components of the search array, but they each have some open variables that haven't been determined yet. The next step is for us to determine that. We can use a code component to define the variables and also see what other variables are out there also need to be defined. Let's open a code component, and again, Python only. And for to determine what the display will look like on a given trial, we should put our code under the Begin Routine tab, so the code will be re-executed every time the search array routine is run. If we put it under Begin Experiment, the code will only be executed once at the very beginning without being updated for every new trial. So let's first try to spell out every variable that needs to be defined in this experiment. This is a visual search task with a distractor present on some trials but not the other trials. And the critical research question we want to ask is whether the search performance will be impaired when there is a salient visual distractor. So distractor presence probability is an independent variable that we want to carefully control. And there are also some less critical variables that, such as the location of different shapes, we might be able to just randomize without very carefully control. So let's first just spell out every possible variable and see how we want to control them. So we have our singleton presence, and we have the when there is a singleton present, we have to determine which of the three non-target shapes will take on the distractor role. And also we need to determine the location of each of the four shapes. And we also have to determine the color assignment on a given trial. And the color assignment is to an extent based on the program version and also based on whether the shape is a target or a distractor. So these are the four possible variables we may want to determine at this point. And depending on the nature of this experiment, for the independent variable, we want to control in a more rigorous manner. Like for singleton presence, we want to set the distractor to be present on 50% of the trials and absent on the other 50% of the trials. And we want the probability to be exactly 50%, as biasing towards either end will bias participants' expectation. And when the singleton is present, we also probably want the distractor shape assignment to be carefully controlled. We want each of the three non-target shape to be equally likely to become the color singleton distractor. So we want to manipulate these two factors with equal probability for different conditions. And to do that, we will have to control the variables in an embedded Excel sheet. But for the other variables, such as the location of each shape and the color assignment to be either red or green, those are less important. The location is less important. We could just randomize it. And regarding the color assignment, it's based on the program version, so we can also determine it here, and it's also based on the assignment of whether a shape is a distractor or not. So we can also assign it using code. So let's first work on these two rigorously controlled variables using an Excel sheet first, and then we will return to this code component to keep coding up the other random variables. To rigorously control something, let's first open up an Excel sheet, and we will need to spell out all the possible conditions of an experiment in Excel. Let's do it starting from the second column of the sheet, because in PsychoPy sometimes the information in the first column may not be saved appropriately in the data file, so I tend to just put down something that won't be so useful in the first column, just in case it's not saved properly. I'll just put experiment name here, and notice that for the text in the first row of the Excel sheet will eventually become the column name in the data file, in the CSV file after running the experiment. So the names cannot contain any blanks. If you want a separation between words, use an underscore rather than a blank. So I can just put the experiment, call it visual search. That's something useless we won't need to know eventually. And then we said we're gonna control the singleton presence probability here, and the singleton could be either present, I'm gonna use letter P for present, or absent. Only two possibilities, and we want them to each take on 50% of the trials. And when a singleton is present, we also need to assign one of the three non-target shapes to be the singleton distractor. So we have diamond, we have square, and we have a hexagon as the three non-target shapes. And to make them equally likely to be the distractor when singleton is present, I'm going to repeat the letter P 3 times, corresponding to the three shapes. And also to match the 50% presence probability, I'm going to also repeat the letter A 3 times. But when there is no singleton present, let's just put down something like an A for the singleton shape. There won't be a singleton shape either. In this way, we have, I'm going to also drag visual search to repeat 6 times. In this way, we have 3 times 2 equals 6 different cell conditions listed here. So that means in an experiment, the minimum number of trials in a block will have to be 6, or the total number of trials will have to be the multiple of 6 to ensure that these cell conditions are repeated altogether with equal probability. Now let's save this Excel sheet. We have to put it under the same folder, the Python PsychoPy tutorial folder that we previously saved our experiment program in. And let's name it visual search conditions. After saving it in the same folder of the file, we can now use the information in the Excel sheet in the search array. And to do that, we will have to first make the search array repeat by inserting a loop. Click on Insert Loop, and then click on the two ends of the search array routine, and then enter some details about this loop. It's by default called trials. That's a good name for us. And make sure to check the is trials checkbox to let the software know that the information here will have to be saved as different rows in the data file to show that there are trials. And to get the Excel file here, we can browse and find the visual search condition that we just created. It's listed here. It says it has 6 conditions with 3 parameters. Double check this to make sure we get the right number of conditions. And for now, I'm just going to make the Excel sheet repeat only once, so there will be only 6 trials in a block. And the order of trials will be selected in random from the Excel sheet. Okay, so this is how the two critical variables, the singleton presence probability and the singleton shape assignment, is manipulated. Now let's return to our code component to keep assigning the other two variables. They need to be done in a relatively random manner, especially the location, and the color assignment will have to be based on the version. And to do the location assignment, let's first list all the possible locations, and we can list it under the Begin Experiment tab because the locations only need to be executed once. They will never be updated every time the trial is rerun. So let's first create a location list. To create a list, let's use a square bracket in Python, and we want the stimuli to be presented at the top of the screen, the bottom of the screen, and the left and the right. So we can code the location as 0, 2, comma, 0, -2, and 2, 0, comma, -2, 0. These are the 4 locations. And to randomly assign the locations, we will have to import a math function in Python called random. To do that, we just type import random. This function only needs to be imported once to use throughout the experiment, so we also put the code under the Begin Experiment tab. Now it's time to return to the Begin Routine tab to implement the randomization function for every single trial. So to randomly assign one of the 4 locations to one of the 4 shapes, I'm going to randomly shuffle the location list and then do the assignment. To shuffle, this Python syntax is random.shuffle, and then locations. This is the variable name we previously used to define the locations in the Begin Experiment tab. And then after shuffling the locations, the location list will still contain the 4 coordinates, except that they will be in a different order as what's being shown now. And then we will going to use indexing to assign each of the 4 locations to different shapes. After shuffling, Python indexing will start from 0, so the first element in the list will be locations 0, and then the second element will be locations 1, and this will be 2, this will be 3. So now let's do the assignment. We previously named the location of the circle as circle log. So let's assign the first element in the location list after shuffling to the circle, and then assign the second elements to the diamond in a similar manner. And the same thing for the square. And repeat the same process for the hexagon. Notice that I typed spaces in between the operators and the variables, but in Python programming, the spaces are not necessary. The code will work the same with and without the spaces. I just type the spaces to separate different things to make the code more readable to myself, but you feel free to not include any spaces if you don't like to. So in this way, we randomly shuffle the locations and assign each and every one of them to one of the 4 shapes. But note that this randomization method cannot ensure that each location being equally probable to contain each of the 4 shapes. This location randomization is a fully random way. It does not have the rigorousness in controlling the variables as what we did in the Excel file. Okay, the next thing to assign is the colors. For the colors, we want most of the array elements to be in the target color, just except the color singleton, if there is one present. So we can first assign everything to be in the target color and then use a if and if else conditional statement to see if there is a distractor present, and if so, assign the distractor color to the distractor shape. So first assign everything to be the target color. We previously named the color of different elements as circle color and equals the target color. And do the same for different elements. And then we are gonna use an if-else statement to see if there is a singleton present, and then assign the singleton color to the singleton shape. If we previously in the Excel sheet we used simpress to denote whether there is a singleton present or not, and then we use double equal sign to check if it equals to the value of p. If it is present, and then we see what shape the singleton distractor is. If sing shape is a diamond, we assign the diamond color as the singleton color. Else, if the sing shape is a different shape, say it's a square, we just do the same for the square. Lastly, if the singleton shape is a hexagon, we do the same for the hexagon. This way we finished assigning the distractor color as well. Now let's save it and put the code, because the code would generate the color and the location for all the 4 shapes. Let's make sure we put the code more upstream compared to these components. To do that, we can just click Move to Top. Now let's run the program in a timely manner to see if everything works correctly. Let's first run program version A to see if the target color being green condition is done correctly, and then we'll return to run the B version as well to see if the opposite color assignment is done correctly or not. Okay, proceed, and let's get started. You can see that the singleton is present on some trials and absent on some trials. And when the singleton is present, it can be equally likely to be one of the 3 non-target shapes. And you can also see the location of the 4 shapes is random from trial to trial. So it seems like everything is working all right. Let's also test run the other color assignment. Proceed. You can see now the target is in red and the distractor is in green. And the 4 shapes look like they're displayed in the desired manner. So it seems like everything is working well. And the next step would be for us to add the dots to the shapes. To create the dots, we will also again use the polygon stimuli to create tiny circles. I'm going to name this one dot circle. This will be the dot on the circle. And the timing of the events will have to be exactly the same as the other search array shapes. Make it a circle, and for a dot, we want it to be very small in size, so 0.2 times 0.2. For the position, we want the dot to be presented on the circle, so the same location as the circle, but along the horizontal axis, we want it to be shifted slightly left to the left or to the right a little bit. So to get that, I'm going to represent the location of the circle as two separate variables, one variable for its x coordinate and the other variable for its y coordinate, and add an increment for the dot into the x coordinate. To do that, because Python recognizes a location coordinate as two separate variables, we can also using indexing to call each and every element of the location. Like the location of the circle is circle log, we can using indexing 0 to get its x coordinate, and using indexing 0 to get its y coordinate, using indexing 1 for its y coordinate. So if I do it this way, this will be exactly the same as just typing the circle log. And because there is a $sign ahead, we don't have to add a $sign by ourselves, but we set it to update every repeat. And next, let's add an increment for the dot. We can call it dot shift. Maybe dot shift, circle dot shift, to specify it's for the circle dot. Okay, this is the way we define the location for the dot on the circle. We'll do the same for the other shapes. And for the dot, we want it to be in black color, and none of the other needs to be changed. And to create the dot for the other elements, I'll just copy the dot for the circle and paste it. This one will be for the diamond. The only thing needs to be changed is for the name circle to be replaced by diamond. And do the same for the square and hexagon. Finally, for the hexagon, repeat the same process again. Okay, then we need to define the what the shifting of the dot will be randomized. Like the list of locations, we can also predefine a list of possible dot shifts. The dot could be either shifted leftward or rightward, so I only need two elements here. Let's say we can shift it 0.4 degree to the left or to the right, so 0.4 or negative 0.4 in the begin experiment routine. And then in the begin routine tab, we now define the shifting of the dot for each of the 4 shapes. to do that, because there are only two elements in the dot shift, we can just randomly choose one of the two. We don't have to care about the replacement problem because there are only two dot shifts, but we will do the same random selection for the four shapes. So for every dot, like for circle dot, let's just randomly choose one of the two by using random dot choice. This is a Python syntax to randomly choose from the list with replacement. And we'll do the same for the other dots. Okay, and after determining the dot location on each of the four shapes, we now need to define the answer to the search based on the location of the dot on the target shape, which is the circle. So if the circle dot contains if the circle dot is to the right, which means it has a value that's greater than 0, the search answer would be to press the right arrow key. And we can define the search answer by typing the key press we are going to use when entering the keyboard component. It's the word right in lowercase in quotation marks. And else, if the dot is to the left, we can define the search answer as left. Alright, let's save it. Now we need to add a keyboard component to collect the responses to the search. Create a keyboard component because this response collecting keyboard is the most important response collecting component in this experiment. It will store the reaction time and accuracy information. That's the dependent variable of this experiment. We're going to name it under a special name we can remember, and we will later repeatedly use that name when computing performance feedback. I'm going to call it search RESP. And the timing should be exactly the same as the search array onset and offset time. And for this one, we will only allow the left and the right arrow keys. And it will also force in the routine. And we want to store the first key, not the last one. We want the first key press to be registered, and we want to store correct. And we previously defined the correct answer to be search answer. So I'll put a $sign to let the software know I'm entering a variable, not a string. Okay, and if we scroll down, we can see that the keyboard component is down below. And double check to make sure that the timing of different events are set to be ideal. Like the fixation should last all the way throughout the 3-second display duration, but the four shapes and the four dots on the shapes should only start from the time of 1 second and last for 2 seconds. And the response collecting component should also have the same duration as the search array. So it looks like everything is set to be perfect. Let's test run the program to see if it is the case or not. Proceed, and ready, go. Yeah, we now see the dots. But accidentally I forgot to remove the border of the dots, so now you see the white border. We can later remove it, but also it doesn't seem to matter too much. Yep, everything seems to be working fine, and the circle dot is sometimes on the left, sometimes on the right. Before we proceed to the next routine, it's really important that we save the data. In PsychoPy, the data that was created in the Excel sheet will be automatically saved into the data file, but any randomization that's done in the code component will not be automatically saved. We have to enter some code to manually save the data, and saving of the data is not time sensitive, and we can put it under the end routine tab, so the code to save the data can only be executed once the search array routine finished running. In Python, the syntax to save data is this exp dot add data. Notice that it follows the same convention in other Python syntax. The first letter of the second word is in uppercase, other letters are in lowercase. And to add data, we first enter what the name of the column we want it to appear in the data file. Like if we want to save the location of the circle, we can also still keep calling it circle log in the data file, and then we enter what's the variable in this program that correspond to the location of the circle, which is also circle log. You can use the same variable name to save it in the Excel sheet in the final data file, or you can use a different name. It's up to you. For convenience, I'm going to keep all the variable name the same, and I'll just copy and paste this syntax for different variables. So we now have saved all the locations. The next thing to save is the color of different elements. We're going to keep using the same syntax, but change the word location to color. And repeat the same for different shapes. Now we have saved all the information for the colors of the shapes, and something else to save under the color category is the target color and the distractor color that were previously defined in the welcome routine, but we never saved them. So we might as well also save them here under the color category. So we now have all the color information saved. The next thing to save is the location of the dots that were randomly selected from two possible options. We're going to use the similar syntax, but just change the color to be dot. And do the same for all the other shapes. What also needs to be saved is the search answer, the left or right answer based on the location on the target dot. So let's also save it here. Okay, seems like we have all the data that was randomly generated from the code component all saved here. The next thing down the stream is to create a trial-by-trial feedback, a feedback routine that can provide the error message after an incorrect key press or too slow message after a missing key press. So we should insert a new routine, and let's call it trial feedback. and also insert it into the trial loop. In this feedback routine, we are going to present a feedback message, which is a basic, just a 1 or 2 word text showing the error or too slow. And we want it to start from the very beginning and last for 1 second. And because the content of the message is based on the performance, we have to use a variable to represent it now. Let's call it error message and set it to update every repeat. It can be presented at the center of the screen, and we don't care about the wrap width because it's a very short term. It can be white, and we want it to be relatively big. And we also want an arrow tone to give a annoying beep sound after an arrow or a missing response. So we want it to be presented for half a second. This tone is default to be a note, which is good for our purposes. And we want to set the volume to be a variable because if the response is correct, we no longer need to present an arrow tone. So if the value is 1, that means it's gonna be pretty loud. You can see when I hover my mouth, here it says the volume is in the range of 0 to 1. So we can set it to be arrow fall. So we will set it to be 0 for a correct response, but 1 for an incorrect response. Next, we will need to define the variables we created for these components, also by using a customized code component. And we will need to put the code under the begin routine tab because the code that generates the feedback message and the volume will have to be executed repeatedly every time the trial is run. So we're now determine feedback based on performance. If the response is incorrect, so we previously called the response collecting component search RESP, and in the data file, the accuracy of the response will be saved as the response collecting component name .corr, and if this entry has a value of 0, that means the response is incorrect. But it could be incorrect due to either reason, due to a wrong key press, or due to a missing response. We will have to later differentiate different situations. But if the response is wrong due to either of the 2 reasons, we want to set the error volume to equal to 1, regardless of what's the cause. And then let's differentiate different situations. If it's due to a wrong key press, then in the data file, the key that is pressed to respond to the key press component is stored as search resp.keys. So if there is any entry in the data file under this column, that means a key was pressed. But if it was incorrect, if this conditional statement is embedded under this first conditional statement, so if it's incorrect, that means the key was pressed was not right. In this case, we will give an error message of error. But alternatively, if no key was pressed and the accuracy was still not right, that means it was a missing response. So we will give an error message of too slow. Alternatively, so this will be alternative to the first conditional statement. Else, that means if the response is correct. Instead, we will give no error message. So I'm just gonna type an empty error message, and we also won't present an error tone. Set the volume to be 0. So this large conditional statement should be able to define the consequences due to either wrong key press or missing response. Let's save it. And because the variable that's defined in the code component will determine the subsequent events, this code component has to be put to the top. Now let's run the experiment to see if the feedback is generated correspondingly after different performances. Proceed, proceed, proceed. I'm making correct responses for now, so nothing happened. But let's try to make an incorrect response. We got an error message. Let me try not to respond for the next one. I get a too slow message, and both error messages were accompanied with the error tone at a presumably correct volume. So it seems like everything is working perfectly. Moving forward, the next thing we need to do is to create a block and also create a new routine called block feedback that will provide the information to the participants and help them take a break. So in the block feedback routine, the participants will see how many blocks they have completed so far and what the mean accuracy and reaction time was in the past block they just completed. And also based on whether their performance meet the criteria that we set, we can either have them grab an experimenter to check on them or allow the participants to resume from the break by themselves. So let's do that. First, we need to insert a loop. Let's start from here before the ready go routine because we want every block to start from the preparation screen and end here. Let's call it block, and there's no need to check the is_trial anymore. And let's have it repeat twice for now. And there's no condition file embedded in the block loop because the only function of this loop is to have the trial repeat several times and with a break in between big chunks of trials. And let's insert a new routine called block feedback at the end of the block. In the block feedback routine, we will provide the participants with the following information: how many blocks they have completed out of the total number of blocks, and what their average reaction time was in the past block, and how many errors they committed in the past block. So to be able to keep track of those information, we will need to first set the variables that record those information back to 0 in the ready go routine, and then in the trial feedback routine. Depending on whether participants made errors or not, we can decide whether we increase the counting variable there. So first, let's go to the ready go routine and add a code component to reset the value of the counting variables. First, let's use a variable called mBlocks to keep track of the block number, and I set it to 0 in the begin experiment tab. So regardless of how many times the block loop is run, this mBlock variable will only be 0 at the very beginning, but it will never be reset at different repeats. And then under the begin routine tab, I reset the other variables to 0. We will need a variable that counts how many trials have been completed. We reset it to 0 here, and we need another variable that resets how many errors were committed. And also we need another variable that keeps track of all the reaction time on correct trials. And we need another variable to compute the mean reaction time. We reset them all to 0 under the Begin Routine tab. So every time this block is repeatedly executed, these values will be back to 0 there to start to count the performance for a new block. And then in the trial feedback routine, depending on participants' made errors or correct responses, we can separately increase the error index and the reaction time counting variable. So if they made an error, regardless of what type of error it is, we always need to increase the error index by 1. And if the participants made a correct response, that's this else branch here, we will count the reaction time on that trial into the overall sum RT. And the reaction time of the trial is recorded in the data frame as search.resp.rt. This is the name of the keyboard component we use. Just use the .rt suffix to record its reaction time. And also, we, regardless of whether participants made a mistake or made a correct response, we will need to count how many trials that's being completed by increasing the trial counting variable by 1, regardless of accuracy. And then going to the block feedback routine, let's first specify what different text messages we're going to present to the participants. So first we want to present a take a break message that also contains how many blocks they have completed so far. I'm going to call this message take break, and it will be displayed at the very beginning and won't disappear until participants proceed. And because the number of blocks will have to be counted in the code component later, I'm going to keep it as a variable and call it break message. Set to update every repeat. And because there are so many messages presented, the first message needs to be put at the top of the screen and have it span across the screen, and change the text to be slightly larger than the default value. And then the second message we want to present is the mean reaction time. So I'll call it RT, and it will have the same settings as the take a break message. But because the mean reaction time will also be computed in the code, the text value here will also have to be kept as a variable. I'll call it RT message. Let's put it slightly lower than the take a break message. And let's use the yellow color for this special message. Similarly, we also create the accuracy message to the participants. present it also slightly lower than the RT message and have it span across the screen. We also use the yellow color for this performance feedback number. And the last piece of text would be an instruction on how to resume from the break. Depending on participants' performance, if they did pretty good in the last block, they should be allowed to resume by themselves. Otherwise, they might need to get an experimenter to check on them. So this resume message also need to be set as a variable depending on performance. And different from the other messages, we may want to delay the onset of this message by a little bit just to ensure that participants have time to read through their performance feedback before the instruction on how to resume is presented. Let's call it resume message. And let's put it at the bottom of the screen. Let's use red color for it because let's differ the color based on the participants' performance. If the participants did reasonably well, they're allowed to resume by themselves. Let's just use the white color. Otherwise, if it's a warning alert to get an experimenter, let's present the message in red color. So let's set the color as a variable. Lastly, we need to use a keyboard component to collect a key press response to allow participants to proceed. And regarding the allowed keys, if participants did pretty good, we can allow them to press, say, the spacebar to resume. But if they need to get an experimenter, we again need to use our secret passkey. But if I specify the allowed keys this way, even if people need to press a P key to proceed, participants can still get away with it by just pressing a spacebar by themselves. So I have to also set the allowed keys as a variable depending on which situation people get into. And because there's already a $sign here, I no longer need to type a separate one. We'll call it resume key. And we don't need to store anything for this. Finally, let's add a code component to determine different situations and also compute the mean performance feedback numbers. We can do it in the Begin Routine tab. First, let's count how many blocks are completed so far. Because this code is under the Begin Routine tab, every time the block routine is run, the mBlock counting variable will increase by 1. Next, let's determine the break message. So the break message will start from feel free to take a break and then show participants how many trials they have completed so far. And here the number of blocks completed will be concatenated after this sentence. So for simplicity, I'm just going to do the concatenation here. Break message equals break message plus the counting of the blocks. The block is counted by using the mBlock variable, but because it's a numerical variable and we're trying to concatenate it with a string variable, we will have to first convert its variable type to string. So to convert the variable type to string, I just type str and put the mBlock in parentheses. And we can keep finishing up this sentence by typing out of the total number of blocks. And the total number of blocks, remember, that's a variable we defined pretty early on in the welcome routine. And it's also in the format of a numerical variable, so we need to convert it as string again. Number of blocks. And then finish the sentence by adding space blocks. And the next thing we do is to compute the mean reaction time and count how many errors were made out of the total number of trials to provide the performance feedback. For the error message, ACC message, the basic sentence we're gonna provide is you made the percentage of the number of arrows, and to do that, to show the number of arrows, we first place a placeholder for an integer here, which is a percentage sign followed by an I. I stands for integer. Arrows out of the total number of trials. We're going to again put a placeholder for integer here and later specify what the two integers are. By typing a percentage sign and in the parentheses we show the first integer is number of arrow, and the second integer is our trial counting variable, number of trial. In this way, the first variable here will be pumped into the first placeholder in the string, and the second variable here will be pumped into the second placeholder in the string. And for the reaction time, we previously defined a variable called mean RT to use to compute the mean reaction time, and the mean reaction time is only the variable sum RT only takes into account the reaction time from trials with the correct response, and correspondingly the denominator also need to be the number of correct trials. So we will get that number by using the total number of trials subtracts the number of arrows. And make a note to ourselves, only compute mean RT from correct trials. And for the RT message, we now can show that your average speed is, and again put a placeholder, a percentage sign, dot to F. So this is a placeholder for a decimal. In Python, decimals are called float variables, and this F stands for float, and this dot 2 means that we're rounding the decimal to 2 decimal places in seconds. And then let's tell the software what's the variable to present there, mean RT. Okay, now we have finished computing all the performance feedback. Then what about the instruction regarding resuming from the break? If participants did well enough, they should be allowed to keep going by themselves, but if they did poorly, we should have an experimenter to check on them. So to determine whether experimenter check is needed, we can first set a criteria. Say if our criteria to decide the performance is good enough is 90% accuracy and reaction time being faster than say 1 second, we can specify it this way by saying if number of errors divided by number of trials is smaller than 0.1, smaller than 10%, and the mean reaction time is smaller than 1,000 milliseconds. Oh, and because Python recognize PsychoPy uses the unit of seconds instead of milliseconds. If we want to represent 1 second, we just need to type 1 instead of 1,000. And let's make a note to ourselves. This is the cutoff we set, 90% accuracy and 1,000 milliseconds RT, or RT below 1,000 milliseconds. Okay, if that condition is satiated, that means the participant did reasonably well. So their resume message could be that when you are ready to resume, press the space bar. And correspondingly, remember that we also want to differ the color of the text based on performance. And if they did well, the resume color could be white. And also, the key to resume can be the space bar. Else, if the participant did poorly, we have to set different criteria to them. I'm going to copy these variables and just change their values. If they're not allowed to continue by themselves, the message would be, please get an experimenter to continue. And the resume color would be red. And the secret key to press would be the P key that stands for proceed, that only the experimenter knows. Okay, we have specified all the information for the block feedback. Let's run the experiment to get to there and see what the results will look like depending on how we did during the block. Proceed, proceed, proceed. Let's first do a terrible block. Let's first try to get the get experimenter message and see what will happen. See, I keep making several errors. Oops, we got an error here. Oh, it's actually a nice error to encounter. You can see that the feedback message is pretty informative. It says the break message was referenced before the assignment. That is because we computed what the break message should be here in this code component, but the code hasn't been put upstream before the take a break component yet. It's something I forgot to do, so let's now move it to the top and try again. It's a really important lesson to learn, like always put your code component at the top of the stream to prevent mistakes of saying like a variable is referenced before it's being defined. Proceed. Let's do a terrible block again. Alright, perfect. So it says we have completed one of the total 6 blocks. That is correct. And our average speed is 1.13 seconds. That sounds like what I did. And we made 3 arrows out of 6 trials. That also counted the arrows correctly. And because we did so poorly, we need to get an experimenter to continue. But let me try just pressing the spacebar, the regular passkey, to continue and see if we're able to get out of here. No. But if I now try to press the P key, we're able to resume to another block. So in this next block, let me try to do very well. Let me try to make no arrows and be also reasonably fast, just for the sake of getting a block resume message to be able to continue by myself. So let's try it. Yeah, perfect. We made no arrows. And our speed was also pretty fast, and it also correctly showed that we have completed 2 blocks out of the total number of blocks. So I should now be able to press the spacebar to resume. Perfect. And although the experiment has a total number of 6 blocks, when setting up the block loop, I conveniently just set it to repeat twice. That's why the experiment terminated only after 2 blocks. I'm going to change it to be number of blocks that we defined pretty early on the welcome routine. If this is the last block of the experiment, the 6th block in this case, we may no longer need to present the block feedback message. Otherwise, it will be really weird for the participants to see you have completed 6 out of the total 6 blocks, but still feel free to resume by pressing the spacebar. So to prevent that awkwardness in this code component, we may need to include some function to keep track of whether this is the last block or not. And to do that, we will need to use the each frame tab. This is the first time in this experiment that we use the each frame tab, and we use it because the command to terminate the presentation of the routine is a time-sensitive one. So if last block of the experiment, no need to display block feedback. The conditional statement would be if the counting of the blocks equals the total number of blocks that we predefined. We use this secret comment called continue routine being false. In PsychoPy, the true-false statement has to be typed the exact way with F in uppercase, the other letters in lowercase. So continue routine equals false means that this block feedback routine will be terminated as soon as the algorithm detects that this conditional statement is satisfied. Click OK to save it. And then the final routine of this experiment would be a goodbye and thank you message routine at the very end. Now let's create that new one. We can call it bye. In this one, we just present a pretty simple text message that will not be a variable but be a constant one. Thank the participant for participating in the experiment. You have reached the end. And then depending on whether you want to debrief the participant in the program or you want to have an experimenter talk to them in person, you can decide what debriefing words you can say here. And you can also include some messages, say, please get an experimenter to end the session. And we want the message to last till forever. And we want it to be presented at the center and span across the screen. And the text to be relatively large. Okay, and something else in this routine is a keyboard component that allows pressing some key to terminate the program. If you allow the participants to terminate by themselves, you can simply keep the allowed keys empty. If nothing is entered here, that means any key press is allowed, and that will force terminate the routine. And we won't collect any data for that key press. At this point, we have successfully recreated the entire visual search experiment that we first saw at the beginning of this video. Congratulations! And before we end the video, I have a few other tricks about PsychoPy that I would like to share with you. Say, in this experiment, if we want to build a separate block that's outside of this existing loop, that would allow us to embed a different Excel file in to control for some different conditions. For example, if we want, in the new Excel file, we want there to be no singleton absent trials at all. We want every trial to have a singleton presence. Then we will need to construct the loop separately. To do that, instead of manually rebuild all the routines, all the redundant structures by hand, we can just insert the same search array routine into the program. You can see that this search array is under the same name as the first search array, and we can also insert a different loop around the search array to create an additional block. But be careful, because if we do this, any changes we make to the second search array, like if we added the code here, the changes will also be applied to the first search array. So in other words, as long as the different routines share the same name, any changes done to either of them will apply to both of them. And to prevent this kind of unintentionally contaminating a different routine we don't want to, we can do it in a different way. So we can copy the routine, make a duplicate, and then name the duplicate under a separate name, and then make changes to it. That way, the changes to the second duplicate wouldn't apply to the original one. To do that, we can copy and paste the routines, just as we do to the components. But if I left-click on the routine, it doesn't allow me to copy it. To copy the routine, we need to first select it, and then under the Experiment tab, we choose Copy Routine. And then again under the experiment tab, we choose paste routine, and then we name it differently. Say I just name it as new array. And to insert the new array, I again need to click insert array. It's down below at the bottom of the list. If I put it here, then this new array will now initially look exactly the same as the search array routine, except that now you see this in the search array, the names of the components are what we initially named them after, but in the new array, the components names all have a underscore 2 after them. In this way, they're recognized as different components as the components in the original search array. So any changes we make to the code here will no longer affect the original routine. So this is a way to quickly copy and paste the routines to save some effort from creating redundant structures. And also, at this point, you may wonder, we have finished building the experiment and we try to run a few blocks by ourselves. And can we see the data? Where are the data stored? They're stored under the same folder as where you saved the experiment. Let's take a look together. We save the experiment under the folder of PsychoPy tutorial. And if we run the program, there will be a data folder automatically generated in the same folder as where we stored our tutorial program. And you can see in the data folder there are so many different data formats, and the data format that is readable has the suffix of CSV. Let's take a look at the data from our last run of the program, in which we run 2 blocks to in one block we did terribly to get an experimenter resume message. In the second block we did pretty well to be able to continue by ourselves. So this is the data file, and as you can see there are some variables that was saved from the Excel file that we initially used to define the conditions, such as experiment name was from the Excel file, and singleton presence was from the Excel file, and the singleton shape was also from there. And starting from here, these several columns saves the response. So the response key column saves what key was pressed in response to the search array, sometimes left, sometimes right, and sometimes none, because we missed the trial. And here is search response.corr documents the accuracy. If it's right, we got a 1. If it's 0, we got it wrong. Remember that in the first block we did terribly, so we got a lot of 0 there. And in the second block, we never missed a single trial. We did pretty good, so it was always 1, the second block. And this search response.rt column documents our reaction time in the unit of seconds. You can see in the first block, we responded relatively slow. And in the second block, to prevent getting the get experimenter message, I responded pretty fast. You can see it's usually half a second. And going forward, the program also notes how many blocks was completed. And this column block, this n, counts how many blocks. We had our own way of counting the blocks using the variable n block, but the software will automatically save a different variable on its own as well. Because PsychoPy in Python indexing starts from 0, you can see this 0 means that was the first block, and these 1s means that these data were from the second block. And also within a block, this n column also indexes the trials, and it starts from 0 as well. So 0 to 5 denotes that these rows were from the first block, and starting from the second block, the trial index was back to 0 again. So these 6 rows denotes that these trials were from the second block. There are also some other information saved, like the onset, offset time of different events. Um, they might be useful for you to check the temporal position of your display, but I seldom use that. I usually just use I the information we introduced before. And here are some additional information that we manually saved in the code, like the location of different shapes and the color of different shapes, and also the location of the dot on different shapes, and the search answer, and additional information, timing of the events. So this is the data file, and that's the end of the tutorial. Thank you so much for bearing with me in this long video. I hope this video is helpful to you in programming. And if you have any problem with programming in the future, feel free to reach out.